Hello,
Hello.
welcome back to another stream on the Perpetual Printing YouTube channel.
Welcome back.
As
Having you.
always, we've got a very exciting stream for you this week. No special guests,
It's just
just
us.
us. You're stuck with us, but we're going to be talking about a very interesting problem in manufacturing, and it's a problem that's kind of come to the forefront over the last I don't know 18 months.
Yeah, pretty recent
Wonder
for,
why?
and it's probably gonna last for quite a while too.
Yeah, and it's something that affects all of you, and we'll be talking about how it affects you, and we'll also be talking about how 3D printing can be used to solve this problem. So we keep talking about a problem. Why don't we tell everyone kind of at a high level what we'll be discussing, and then we'll do the rest of the intro.
Yeah. So today we're gonna be talking a bit about spare parts. Um, what is like the spare parts crisis? Because there's a bit of a crisis going on. Um, we're also gonna talk a little bit about what currently are the options for spare parts. Um, what other companies are doing, what the norms are in the industry. And then we're also going to talk a little bit about how automated 3D printing can be the solution to plastic spare parts um, due to a wide variety of cool benefits. Um, and then we're going to talk about some results of a white paper that I worked on recently, talking about how um, automated 3D printing is competitive with injection molding for spare plastic parts for quantities up to 300,000.
Yeah, so that's a super exciting result, and it's definitely not what you would expect. Um, but I guess before we get into all of this, for anyone new joining us, I'm Mateo Pekic. I'm one of the co-founders of 3DQ, and I worked on our base technology years and years ago, and I'm joined by Steven McCulloch. And what do you do here
Yeah, I'm the product lead at 3DQ. So I
for?
work on Quinly, which is our main product.
Yeah, yeah. He works on making the 3D printer automation something that you can buy and set up on your own printer. Um, and yeah, so what we're aiming to do with this stream and with this channel in general, well, we focus on automating 3D printers to scale them for mass production. And we want to use this YouTube channel as a resource for anyone who is looking to use 3D printing as a means of manufacture and to learn with us and to learn from us, like because we've been using 3D printers for manufacture now for uh, well over a year in-house, and we also are highly involved with our customer base, some of whom are making thousands of parts a month, actually running full scale productions on
Mhm.
3D printers. So there's a lot of things to be learned and a lot of knowledge to be shared. And if you're watching this later, we also have a community Discord where everyone who's interested in this stuff can join. But if you're here with us now, we'll be watching the live chat as always. So if you've got any questions or comments that you want to bring up as we go through the spare parts crisis and Steven's white paper, feel free to post them in the live chat, and we'll get to the comments pretty quick.
See, Kevin and Bob are in the chat. Hello, guys.
Yeah, nice to see you. Um, so with all that out of the way, what is the spare parts crisis? Because I know this
Well,
is.
we do want to get into the beta
Oh yeah, yeah,
testing
right, right, right.
first.
True. That's
Um,
correct. Now that people have had time to join.
yeah, we've recently started working on um, Quinly for a whole bunch of new printers. Because there's a lot of you out there with printers and you want automation, but you don't have, like, we don't support those printers yet. Um, so what we've gone and done is looked at what are the most popular printers that you guys are wanting automation on, and so we're going to be working on this beta testing to get that out there. So currently we're looking at CR10 line, the Sidewinder X1 and X2 line,
Hmm.
and also the CR6 SE. So these are all popular printers that you guys are interested in getting automation for.
Yeah, so we've actually we've started. I mean, we've always worked with our community to test products before they get launched, and we've actually just formalized this process now. So if you have a printer and you're interested in automation, and we don't already have a kit for it, you can sign up to be a beta tester and actually get like early builds of software, early builds of hardware, test fit things, and like it's actually a really cool and fun process because
Yeah,
we kind of get to build the future of 3D printing together, and like so far the reception has been like really good, and yeah, it's just a really fun process too because you
hmm
get to see your printer get transformed into like a whole production system
yeah,
over the course of a couple weeks. So if you are interested, where can people go to sign up?
yeah. So if you go to the shop, just on our main website, the top right corner is shop, and then we have a whole tab at the top now for beta testing. Click on that. There's an email address. Um, so
Yeah.
you send an email, or I'm sorry, put your email in there, and you'll get instructions on how to sign up for beta testing, and you'll actually get a weekly update on sort of what we're doing next, what the status is on all our beta tests, and yeah, like what's closing, what's starting,
Hmm.
what's in progress. So we're looking at doing one email a week.
Yeah. And it'll be a cycle. When you join the beta, there's also a special group of channels in our Discord uh, that you'll be admitted to with all the other beta participants uh, down here. So you can see we've got quite a few in progress right now, mostly the CR10 line because Creality really loves having thousands of variants of each printer. Um, but yeah, the Sidewinder, Prusa Mini, the Genius X1. Some of these I don't think we've announced yet, so
They're little placeholders, I guess.
consider this an
As
announcement, I
a
guess.
sneak peek, things that we're thinking about.
Yeah, but if you've got any of these printers or you're interested, you have a printer that we haven't listed on our site and you're interested in joining the beta, definitely sign up here. And yeah, you'll get all the information. Yeah, it's super cool. And then of
Yeah.
course there's like a lot of benefits to being a beta tester to being early.
Yeah, so a couple things. If you're beta testing for us, you get a discount um, more than the pre-sale. So whatever the pre-sale price is, that's already a discount on the normal price. There's going to be a further discount to that. So
Hmm.
just as a thanks for helping us out, and we need beta testers, so it's kind of a win-win. Um,
Yeah,
and
the
another thing, sorry, go ahead.
I was gonna say the other thing is you also get to use and show off your kit for your printer weeks before anyone else does.
Hmm
So if you ever want to flex in 3D printing discords, you should sign up too.
Yep, yeah, we've also actually set up a beta testers lounge, so all the beta testers can talk to each other and collaborate on things. Um, yeah, it'll just be a good, cool place to hang out. Maybe just to give a brief idea of what the beta testing process timeline looks like. We're aiming for about 6 weeks. So by the time that you receive your kit, shouldn't take more than a month and a half before your beta testing duties are over. So what we'll have is a couple points of contact in between the point where you receive your kit, where you are done testing, um, and finally there'll be like a form where you fill in, final notes on hardware, software, installation process, and a couple pictures. You could send that all to us. It'll all be in a form, so you don't need to worry about the details. But
Yeah, it's pretty cool. Like you get to be part of the actual engineering process, which
yeah,
I don't know, some 3D printers out there, I wish I was part of the engineering process because oftentimes when you're in the developing space and you're making a product, there's a lot of feedback that or things that you might not see but others will, and we found that to be very true with all the betas we've done so far. So
Yeah.
yeah, it's cool to finally have like an actual process for that.
Yeah, it's actually quite difficult to put myself into the mind of like a user, customer, not the guy that's making it, but the guy that's using it.
Yeah.
It's something that I have to do a lot, but it's still, easier just to get actual customers. Hey Pat, how's it going?
Pat is asking, does the Genius X1 kit work with the new Pro model? I think that we're going to try to support that, right?
Yeah, so we're looking at right now the Sidewinder and the X2, which are both artillery products. And I know the Genius is very similar to the CR10 Pro line too. So the development for that probably won't be too difficult. However, we're not looking at the Genius right now, but it is in our sights. It's just not in our current round of beta. So
Yeah, but
stay tuned.
if you are interested in testing for that, please sign up.
Yeah, I think
Because
I think he might actually already be
yeah,
signed
I think so
up.
too, actually. I
I
feel like
recognize the name.
I've read this email before.
Cool.
Um, yeah, we'll come back a bit, because a lot of people filter through, but we'll come back a bit to the beta stuff
Yeah.
later. But why don't we get on to our main topic, which is the spare parts crisis.
Yeah.
So, what are spare parts and why are they a crisis?
Right. So, if you've ever had to repair something, or if you had an appliance, for example, a dishwasher that's broken down, um, you need to replace parts in it. So, various things in your dishwasher could break, buttons, knobs, spinny parts, little plastic wheels. There are tons of spare parts, and every product out there that's kind of a large appliance, for example, um, has to be kind of repaired, right? You can't just like throw it out and get a new one. It doesn't really make sense to do that. So, um, manufacturers who create these large appliances have kind of an obligation to supply spare parts for them. Um, Otherwise, whatever they create, if they break, people have no way to repair it themselves and causes many issues like tons of waste and people having to buy new things.
Yeah. Yeah. You wonder, like, when you buy a washing machine, it comes with like a 10-year warranty. So, how
Hmm.
do they make sure that there are enough parts for those 10 years? And we're going to also talk about how recent events, recent supply chain issues have affected that particular portion of manufacturing, that specifically supplying spare parts. Because,
Hmm.
yeah, you don't want to, with something that big and expensive, you don't want to have to throw it out every time it breaks. That would be incredibly wasteful.
Yeah, doesn't make sense for a whole lot of reasons. Just keep what you've got and repair it. It's the environmentally friendly thing to do too.
So that's the crisis. And you're also going to tell us what's wrong with the current method and how 3D printing can be used to supplement spare parts. Um, and
Hmm.
this is all covered in the white paper you wrote, right?
Yeah, so there's a bit of background initially, just kind of talking about the problem, giving a bit of background on what's currently done, and then the rest of the white paper is outlining kind of our solution, at least the plastics, and sort of the benefits of automation and digital inventory. Finally, we actually go and crunch some numbers, comparing the cost of injection molding to automated 3D printing, and actually comparing automated 3D printing to manual 3D printing, um, just to show what the part cost would be. So um, it'll be interesting.
Yeah.
I can assure you.
Okay. So while we talk about this, I'll put some cool visuals in the background.
Yeah, these were fun to film.
These are super fun. Okay, so let's start from the top then. What actually is the spare parts crisis like that's
Right.
happening right now?
So the crisis kind of involves the right to repair laws coming in right about now. Um, and it's also being compounded by COVID, basically.
Mm-hmm.
Um, so what the right to repair laws um, basically say is that people who supply large appliances have to also supply parts for them. And in most cases, it's not for like 2 or 3 years, which is actually kind of what it used to be. But they're now saying, yeah, 10 years, you got to supply for 10 years.
Hmm.
And a lot of companies were used to supplying parts for 2 to 3 years, and then their product kind of gets out of date or whatever. They don't supply parts for it anymore. Other people might, but they don't have the responsibility to do that. So the crisis is now it's actually their responsibility still, and they have to supply these parts for 10 years. And what that means is we're going to have to be figuring out how we're going to store all these parts, how we're going to organize them, how we're going to get them from, somewhere in a warehouse to the customer. And just because of this huge multiply of how much time you have to supply parts for, that's going to cause so many logistical issues. So bigger warehouses, longer time from bin to customer, um, longer shipping, larger handling fees. It gets complicated. So we're trying to look at ways that our automation can help solve that problem.
And actually, this is going to be interesting. Pat says that he got his start in spare parts.
Cool.
So yeah, it's going to be really interesting to get your insight throughout this stream, Pat. Yeah, appliances, handles, knobs, etc. The prices from OEMs can be ridiculous, and we'll talk about why it's so high. Um, but yeah, like sometimes, you're paying 70 or $80 and waiting a couple weeks just to get this one thing to get your entire appliance back up and running, which
Hmm.
seems ridiculous, but when you learn, and Pat probably already knows this, but when you learn about how spare parts are currently produced and maintained and warehoused, you'll understand why it is that expensive. And
Hmm.
yeah, it's ends up being really bad for the end customer because they're, waiting and also paying a ridiculous amount of money just for, tiny little plastic part. So, um,
Oh, yeah, look at that. So your knobs on your oven broke.
they were $77 each. He broke three,
3 knobs.
and it was half the cost of the oven. Yeah,
That's
like
insane.
exactly. Like that, and that's the problem. And part of it comes from, you know, the same thing that makes your oven really cheap to buy in the first place is the thing that makes spare parts really expensive.
That's a good quote.
Thank you.
It's
Yeah.
true though, because ovens are mass produced and spare parts are mass produced. And when all the spare parts are kind of combined into one appliance and sent as a whole unit,
That's fine.
it's fine. But when you have to like send little bits and pieces from here to there, it becomes really expensive.
So when did these right to repair obligations, is that quite a recent thing, or is it more that we're starting to see the effects of a decision that happened a long time ago?
Yeah, it's been sort of like I think a slow burn over the last like 15, 20 years actually of people saying like, "Oh, I would like to keep being able to repair this."
Hmm.
And
A reasonable ask.
reasonable ask, yeah. I don't want to go into details on names and companies and stuff, but for example, like you're not able to replace a battery on a certain phone
Without
because they
destroying
have
the phone.
yeah, well, they have serial numbers built into them and stuff, and it's hard to you just can't get it to
Hmm.
work unless they're supplied by a particular manufacturer. So you kind of a lot of consumers are limited in what they can do with their products. So they've been asking for right to repair laws. And I know in Europe it's become pretty big, and even in North America now it's starting to roll in. So it's reasonable to expect it's going to become a worldwide thing eventually.
So, um, okay, so right to repair is one issue. So the fact that these, I guess, warranties or availability of spare parts have been extended from a couple years to a decade or more.
Yeah.
Um, and like, why? So why does that make those replacement parts so expensive? Like, what's wrong with having to warehouse spare parts for 10 years?
Yeah. So when you want to create like a stock of spare parts, that involves usually doing a huge run of injection molding or assembly or whatever your parts are made of, but let's talk about plastic here. Injection molding, and that's not a cheap process, but also the storage and maintenance of those parts itself also has costs. So like the warehouse space, for example, has rent. You have to pay
Mm-hmm.
for square foot every month. There's electricity, heating, lighting, AC. Humans have to work in this environment too. So all the space that you're using to store parts is also space or money that you're spending just to keep them there. Um, and shall we go into like the cost of injection molding, for example? Um, like I know.
Yeah, like why? So injection molding, that's kind of what I was getting at earlier. Like injection molding is the reason we can get these products so cheap at such a huge scale.
Mhm.
But it's also kind of the reason why a use case like supplying spare parts isn't compatible. It makes it really expensive. So why is that?
Yeah. So when you're doing a large run of parts, um, commonly it's a good idea to overproduce all the parts just to make sure that you have enough. And what this results in is you have a huge space in your warehouse dedicated to, you know, a bin of parts that you overproduced just to make sure you had enough for 10 years.
Hmm.
Um, and there's also, just logistically, you have to get the parts from the warehouse to the person, and that tends to involve a lot of steps. So you gotta have someone actually pick the part out, package it, ship it, like bounce around a few times during shipping, and that's how your oven knob just gets to be like $77 because, um, yeah, it just takes time and energy and labor to get that part from inside a dusty bin on a top shelf of a warehouse down to you halfway across the world.
Yeah, and I can imagine like because so one of the big problems with injection molding is getting it going. And
Hmm.
so it's pretty infeasible to, start another production run 5 years later to produce more spare parts. It'd be way too expensive per part, right?
Yeah.
So you're talking about overproduction where upfront, I guess they estimate like how often a part may break, in addition to a whole bunch of other things, and then they just try to produce all of that inventory up front.
Hmm.
But that I guess that also means that you would have just some parts that take up inventory space for the whole of those 10 years. And what if no one uses them after 10 years? What happens?
Yeah, so what happens is you had a whole bunch of money basically locked up into these spare parts for 10 years.
Mm-hmm.
No one used them, no one bought them, and now you have to throw them away or recycle them, hopefully. Um, but you have to dispose of them at the end of the life cycle. Um, because yeah, you support, maybe a machine that very few people have or use anymore, and the need for these parts is dwindling. And if you've overproduced them, which you probably have, now you've just got a bunch of plastic in a bin somewhere that's custom fit for this one machine, so you can't use it anywhere else.
Yeah, I see. That makes sense. Like it ends up just locking up capital, which makes making products very expensive. And you might not even use those parts in the end. So you might have locked up, capital for 10 years and then only to throw it into the garbage at the end of those 10 years.
Yeah,
Which, yeah, that really, yeah, that makes sense. Like why it's so expensive to get spares. And that sucks for anyone buying anything. Like
yeah.
it's, yeah, it makes it ridiculous. And I think part of what we've seen with these kind of these companies that are against right to repair is they'll tend to design products in a way that they just become obsolete and force you to buy an entirely new product so that they don't have to inventory
Hmm.
spare parts at all, or they'll charge you more than it would cost to get a second gen product, for example. I've
Yeah.
seen that too. Like, well, it's basically what Pat was mentioning, where to get those three knobs replaced, he would have had to if he didn't have a 3D printer, he would have had to pay half the price of the stove that those knobs came from. And
Hmm.
at that point, a lot of people, myself included, would be making the calculation like, well, why don't I just, if I'm going to spend, $210 um, fixing this old stove, how much more is it going to cost me to just buy a new one?
Yeah. And that's just a knob, right? Like, imagine if it were some internal component that you couldn't maintain by yourself. Maybe it's too dangerous or just
Like yeah, I don't know, like a fruit flavored cell phone battery or something.
yeah. So things that are either infeasible for, us as consumers to work on ourselves, or just maybe too dangerous. So you have to have a, actual technician come over. Um, Sometimes you look at the price of a repair, labor plus the spare part cost, plus whatever fees, you might as well just buy a new machine at this point a lot of times.
Yeah.
So,
And I think a lot of companies kind of exploit that in the sense that they push you to buy newer products so that they don't have to inventory stuff for old products,
mhm.
um, which is, yeah, disincentivizes you from making good, long lasting products, which is not what anyone wants.
Yeah, like I don't think anyone appreciates planned obsolescence, for example, things that are designed to break in a few years so that you don't have to support it.
Hmm.
Um, Unfortunately, it doesn't seem to be a good business model to make products that don't break. Uh, we've seen a lot of companies that do that end up actually regretting the decision because, they only sell once, whereas other people sell multiple times.
Yeah, so for anyone joining us just now, we're talking about the spare parts crisis, which is kind of related to, and we'll get into why now, but related to some of the supply chain issues we've been seeing uh, happen over this last year. But it's actually, like you said, it's been a long time brewing, and part of the cause of this crisis is also part of the reason that, products can be made so cheaply in the first place.
Hmm.
So it's kind of it's very counter to research and development of new products. Um,
Yeah, it's funny how like mass producing has sped up technology so much, but it's also slowed down a lot of other aspects of development.
yeah, I think it slows down innovation and it increases the barrier to entry for innovation,
Hmm.
but it definitely speeds up things like consumerism, which is what makes money. So
Yeah.
that's why I think we've seen, people steer right into that. And that's not to say mass production is a bad thing. I think it's a great thing. But the sacrifices we've had to make to use things like injection molding or machining for mass production has ultimately now started to come back and harm us, which we're seeing
Hmm.
with all of these supply chain issues. Um, in order to make something as hard as injection molding like feasible and cost effective, you have to make really anemic supply chains to countries thousands of miles away where you
Hmm.
exploit a cheaper workforce. Um, yeah, and now we're seeing like here's what comes from it, and it's not good, and it's going to cost us all far more in the end than we would have thought. Um, Kevin with a very important comment.
Mm. Hit
Hit
that like button.
hit that like button. Let's try to get everyone to hit the like button. And welcome, Ben. Good time to join because we're just about to get into the next part of the topic. So we talked about warehousing costs, we talked about inventory costs. We didn't really talk about production costs too much with injection molding, but maybe just
Hmm.
to give people a sense, like what goes into the production costs when you're looking at something like injection molding.
Yeah, so I guess this is actually aimed at both, I guess, industry, but also people who haven't actually started producing stuff yet.
Mm-hmm.
Um, because, back in the day before 3D printing was a thing, if you wanted plastic parts that were complicated shapes, you probably injection molded them. And you could probably only do that for large quantities of parts. Um, and the reason why you can only do that is because the mold itself is very expensive. Because it's a custom machine piece of metal, usually steel, and it's got really complicated, geometry built into it. And it's got to be good tolerances. It's got to be able to withstand, good pressure. Um,
You need an expensive machine to make it. So usually
Yeah,
you'll commission it to someone, but commissioning is really expensive too.
yeah, it takes actually a lot of skill to design, right, the tool paths to machine these molds out. If you make a single mistake, then you have to do the whole mold over again.
Yeah.
It's a very complicated and expensive process to actually make a mold. So you're looking at maybe 15K minimum for um, like a decent injection mold.
Hmm.
And if you look at the white paper, we've been using numbers around that ballpark to get our numbers. But yeah, the cost of the mold itself is a significant chunk of the actual injection molding cost. Uh, then actually, once you buy the mold, you actually have to pay per part. Um, Actually, in our calculations, we've just neglected that because it's too hard to calculate.
Hmm.
So we're just being conservative and saying the parts are free after you bought the mold.
Yeah.
Um, so
So that's going to be a very interesting comparison. And
yeah.
I think 15K for a mold is very, very reasonable if you're not doing, extremely simple parts.
Mhm.
Um, sometimes I've heard people getting away with like really cheap ones, but they can only be used like a dozen times, and it
The aluminum molds are cheaper, but they have cycle lives of like I think 5 to 10,000, whereas the
depends on your tolerances. Like
steel molds
sometimes
are larger.
sometimes it's even worse. Sometimes it's like 500,
Right.
or sometimes you can't even use it for certain shapes because it's not like it won't keep tolerance well enough. Um,
Right.
but yeah, definitely. Um, so yeah, that's one of the roadblocks that everyone is aware of with injection mold is there's a massive upfront capital investment. You buy the mold up front. You don't even know whether it will work or not. So you spend a lot of engineering resources making sure that this one mold you make is the mold that you want. And then you have to buy all of your parts up front. So when a company, like when your washing machine says it has a 10-year warranty, Panasonic or whoever's making it has to buy 10 years uh, worth of parts, basically the 10-year product cycle. They have to buy that pretty much all up front or within the first couple of years of the product's lifetime. And I mean, it makes developing stuff like that really, really inaccessible and really expensive.
Hmm.
Um, so how does automation change things? We all know that 3D printing is a very inexpensive manufacturing technology. Like you can make a part for a few dollars and it'll cost you the same every time.
So that oven knob probably was less than $1
That's what he said, yeah.
worth of plastic.
Pat was
So
saying it cost him less than $1 versus a $77 spare part.
yeah.
So pretty huge change. Um, so yeah, so 3D printing is seems to be a good method for making low volumes of parts, but how has automated 3D printing changed that?
Yeah, so the answer is labor. If you guys know about us, that's what we do here. We automate 3D printers. Um, and the reason is because every time you have to touch the printer, you get interrupted and you have to have a human present.
Hmm.
And every time that happens, you lose 5 to 10 minutes time resetting the printer, taking the print off, scraping it. A lot of times you'll have to clean the bed with IPA, isopropyl, um, apply a glue stick, hit the start button on your printer, and then go back to what you were doing.
Hmm.
And this is actually how most print farms operate.
They have a guy,
They have a guy, and the guy does this a lot of the day,
or all of the day
all
sometimes.
of the day. I haven't actually talked to a
Yeah,
print operator like this because we don't actually need one.
but yeah, there's sometimes a person designated as the part scraper,
Yeah.
and that's their whole job. And yeah, I've been told that it's not a happy existence.
No, I mean these people are smart probably. If you know how to use a 3D printer, you probably, done a lot of cool things with it. You don't want to be spending your time scraping parts.
Yeah.
You can be optimizing G code, you could be designing new things, you could be doing actual, useful work using your creative human brain.
Yeah.
So, yeah, we don't want to be doing any part scraping. That's the benefit of automation. It takes that whole um labor aspect of 3D printing out of the equation. Um, so what we're looking at here is you can produce parts with zero labor cost, close to zero labor cost.
Hmm.
Um,
The actual production is essentially zero labor cost.
yeah.
You can now invest that labor into things like design and optimizing production so you can get more out of your printers. And we'll
Hmm.
talk about that in a minute, but just keep that in mind as Steven talks.
Yeah. So manual 3D printing is good for small production runs. Like if you have to print 100 parts, you could probably do it on a normal 3D printer, given a few weeks, given a few printers, given 40 hours in a week, that's not impossible. Um, but if someone were to ask you to do 10,000 parts, that's just a huge number. You'd be like, why would you ask a 3D printer to do this? There's injection molding, for example.
Actually, Ben E. Brady has a really good use case where regular 3D printing comes into play, which is um, custom vintage parts for older cars where the parts are no longer available. So
Right.
if you can't even obtain that part, it makes sense to invest all of that time into designing a new one and
Hmm.
manually printing one because you might only make a dozen of them or even less.
Yeah,
Um,
and that's actually a good point. Yeah, a lot of products, before 2000 or whatever, probably don't even have CAD files for them. You can't find STL files for like, you know, 1960s car parts. It's
the
just not going to happen.
oldest the oldest version of AutoCAD that I know is 2000.
2000?
So, that I've used. So
Yeah.
uh,
So let's call it 2000.
I don't know if they could do 3D either. It was all 2D drawing.
Yeah.
I'll have to ask my dad, but yeah, so it is, and a lot of the time you'll have to recreate stuff from drawings. So for really low run parts, for really these are generally called like um, low volume, high impact parts.
Yeah.
Um, it makes sense to use 3D printing as it is nowadays. But what happens if you stumble across one of these parts that could be valuable to other people and you need to scale it up? That's where automated 3D printing comes in because it
Mhm.
solves, like you said, it solves that labor issue. And then how does automated 3D printing um, impact things like the manufacturing of spare parts? Like how would it be different than what's currently done?
Yeah. So if you've heard of the term lean manufacturing, it's kind of a process where um, you don't have like an excess of parts. You don't have huge warehouses full of too many things. It's lean. It means, you know, just enough.
Hmm.
Another good one is just-in-time manufacturing, which is how 3D printing actually helps. Um, so, or you could also hear it be called on-demand manufacturing. So, um, if you imagine how an automated 3D printing setup could work, what would likely happen is there would be a small farm of printers, and there would be a small, maybe 20 or 30 part um, sort of cushion, I guess you could say. So you'd only really need to keep a small inventory of spare parts because you're not sending out hundreds of spare parts per day, especially for most small plastic components. They're not breaking all the time. So you might have, 5 or 10 or 20 to send out in a day. Um,
And that actually drops off with time, right? Like
yeah,
at the
true.
end of
That's a
the 10
curve.
year warranty, you might be sending one of these parts a month.
Hmm. And there also could be parts that you've got in your appliance or your product that have been designed so well that they never break.
Hmm.
And congratulations, you didn't need to waste all that money, injection molding thousands of parts only to not ever need to use them, because they were so well designed in the first place.
Yeah,
So,
which is also like it's a real problem because you don't know. You can only estimate so far like which parts will break over the course of 10 years and which parts won't. So you have to
mhm,
overproduce everything.
yeah. So automated 3D printing is a way to print parts on demand, keeping your inventory sizes super low, and you're able to replenish those at any time because your printers can print any part whenever.
Hmm.
So, and that actually could happen overnight as well. So, say a customer needs, a new, very rare spare part. You don't even have them in inventory because no one's needed it for the past 2 months. Well, if they order it overnight and your printers are automated, it could actually, um, you know, imagine a Quinley with some sort of integration with a company's inventory. You could just automatically start that print connected to that part and have the part waiting in the morning when the person arrives to send it off.
Yeah, and the company, and that could happen, you know, one day after the product was discontinued, or it could happen 9 years after the product was discontinued, and it would cost the company the same as
Mm-hmm.
if they were producing it for the first time, which is what the really important thing is, and part of the reason it solves the cost issue with spare parts is because you're not having to include the warehousing space and like all of the logistics spend you would normally have to do when keeping a physical inventory of hundreds of potential spare parts.
Mm-hmm.
With 3D printing, that part only exists in your warehouse for a couple of hours before you send it off because you just make it to demand.
Yeah.
So it costs you very, very little in terms of warehousing. Um, and the other really cool thing that you can do, because you're now moving that all of that inventory into software, and that's called digital inventory, is you can even have multiple locations across the country and have the spare part produced very close to the end user.
Mm-hmm.
And that makes a huge effect on the actual cost to the end user as well, right?
Yeah, so that's what we call digital or distributed manufacturing. Um, Having multiple clusters of printing sites available, um, so that you don't have to get parts shipped from across the world or across the country. It could just be, from your local, your closest distributor.
So I know we're about halfway through the stream right now, so it might be good to give anyone that's just joining us a bit of a recap of what we're talking about.
Yeah. So I guess we should talk a little bit just again about our beta testing that we've been doing um, internally. Uh, so what we started recently is a beta testing program for um, a few new Quinley products that we're starting. So we've actually recently been doing CR10 line of printers, CR6 SE line, and the Sidewinder X1 and X2 from Artillery. And if you've signed up for a beta testing as a beta tester through our email link, um, you'll have gotten emails with that news. But if you're just looking at us for the first time and you have a printer that we don't yet support, if you go to our shop page, there's a button here, beta testing. You can plug your email into there and you'll get some information about our beta testing process and the status on what printers we're going to support, what printers we're currently supporting, and what's going on with our beta test program. Um, just a weekly newsletter essentially, but specifically for beta news. So no, nothing else.
Yeah, and if you want to see automation available for your 3D printer, by signing up, that lets us know and telling us about your print farm or the printers you have, that lets us know where to focus on next. So as Stephen
Mhm.
mentioned, I mean, by doing that same thing, we're um, betaing the CR6SE, the CR10, um, the Sidewinder, and potentially even the Prusa Mini and some other machines. Um, yeah, so sign up and let us know, and you can be part of the development process with us, which I think is very exciting. It's
Mhm.
it's nice to be able to give feedback to a product while it's still in development. I know many of the 3D printers I've bought, I wish I could have given them feedback before
Mhm.
they launched. Um, but yeah, so like basically you can sign up. We've got a special um, chat room in the Discord where you and the rest of the cohort can get new software, get new hardware, try it out, see how it works for you and for your application, give us feedback, and then we'll go and do another round of testing. And together we can help bring 3D printing into the future of manufacturing, and I find that really exciting. And,
Yeah.
yeah.
So additionally, yeah, if you help us out, yeah, being a beta tester, you do get a discount on the pre-sale price. So it's actually two discounts built into
Stacked.
that. So it's a pretty good deal. If you want to help us out, the link's on the website.
Yeah, 3dq.com. You go to the shop, the beta testing sign up form is right there.
Cool. And let's give a bit of a recap on what we've just been talking about. So the spare parts and the white paper that we've been working on recently. Just looking at chat.
Yeah, sorry, I was just reading Just in 3D is ready for the Sidewinder beta.
Oh yeah.
What does he say? What are you doing tonight on demand? Yeah, and Pat is waiting for the WooCommerce store plugin.
Yeah.
We have a design for Shopify, I think, and Etsy. Like there's a design proposal that I have someone. So
Yeah. Imagine when an order comes in, your printer starts printing.
I mean that's what we want.
Wouldn't that be great? Yeah,
Yeah.
we want that too.
Yeah.
That's
For our kits, for our printers.
because that's true. We will be the first spare parts warehouse digital inventory
That we should actually
setup.
talk about that because we've sort of been talking about it abstractly, and it might be a good way to recap as well. So we're talking about the spare parts crisis and why spare parts are so expensive, and then like why it's actually become a crisis in the last year or two. Um, because this has affected everyone, I think, and anyone who's had to get a spare part sees the bill. Like, why does in Pat's case, why does a knob cost me $77 when I could print it for $1? And why does it take 3 weeks to get here?
Yeah.
Um, yeah, maybe if you give people why like really quickly.
Yeah, well, I think maybe just to take it a slightly different angle than last time, because you can always rewind.
Hmm.
Um, we've learned a lot because we developed the automation for 3D printers, and by doing so, we've actually learned a lot about kind of the economics of storing parts versus printing them to demand. Um, and so we've actually learned that it's actually super cost effective to do inventory in this way. And that's why we use our own printing system. We have a print farm just across in the other room there with a whole wall full of printers. And we produce all the parts for all of our Quinley kits on demand. So we're pretty much the first people to do this system. And it's only going to go more from here. Because we could never have done this with injection molding, for example. Um,
It
like
would
just
have been
imagine what,
impossible.
like it would have cost too much. We would have probably had to wait so many months to get our parts from, starting from the design to actually parts in our hand. Quinley might even be a thing in 2022 just because of all the time it would have taken, especially during COVID.
Yeah.
So 3D printing and the automation has actually helped us get products to market really quickly. Um, and
Which
we're
is
looking at maybe a couple months for these betas tops. So
yeah,
it's pretty good.
it's the whole point of the beta program is we can't test as fast as we can develop.
Hmm.
But all of you guys have been
Yeah.
immensely helpful so far. So, um, but yeah, it that is a good angle to look at. Like we, because we were using 3D printing and because it's a prototyping technology as well as a manufacturing technology, we're able to instantly and seamlessly transition from a test part to a final part for manufacturing in the sense
Hmm.
that we might do iterations on a part. Yeah, I'll just throw up a video of one of the parts being printed, but we might be doing iterations of a part over the course of a couple weeks and coming up with new designs. But as soon as we get one that's good, we can say, okay, go in Quinley. Now I want 50 of these, and instantly, like within a matter of seconds, start um, manufacturing directly from the prototype.
Hmm.
And that has been, you know, uh, kind of invaluable to the development and manufacturing process. And then what's really cool about what you're saying with the making parts to demand is whenever we have to transition to a new or a better design, we don't have to wait for, Quinley 2 to come out. We can just start transitioning our inventory over because we
Hmm.
don't have, a massive sunk cost in our inventory. We only have a few days of inventory at a time ever.
Yeah, well, actually, some of the people in chat here will have parts from different, like older versions of Quinley that we sold back in February
Mm-hmm.
have different parts in them than the Quinleys we sell now. And we've actually gone through, I think, 4 major revisions now to the parts, taking in feedback from you guys and just internal testing. Um, so it's really helpful for us to continuously improve our product without creating a new product. We can just make the current one better.
And that does play back into the spare parts in two ways. But I just wanted to read one of these comments from Justin 3D. He said, "Is the spare parts crisis caused by the hundreds of container ships off the coast of California?" And I would say it's not. It's those container ships are actually a symptom of what causes the crisis. I would say that it's a symptom of the way we've had to set up our global supply network, which is by having, you know, supply chains that are thousands of miles long, but in the name of profit have been shaved down as much as possible, which makes them extremely, exposed and weak against any sort of perturbance. Like in this case, a global pandemic kind of caused
Hmm.
everything to fall apart because there's no resilience built in because it's not cost effective to build in resilience with a network like that, like the supply chain network that we have. But something really cool about automated printing is because it doesn't rely on insane volumes and high centralization, you can spread your printers out everywhere.
Hmm.
And if some kind of localized event does happen, like let's say, um, you know, the port in California can't process all the parts produced there, you can just move production and shift production to other locations. And that's infeasible with things like injection molding because it relies on economies of scale and
Hmm.
economies of scale all in one physical location. So you end up just making dozens of these bottlenecks that like it's kind of crazy to think that like one port going down can affect the entire continent. Like it seems like a bad system when you think about it, right?
Yeah. Well, just the fact that the cheapest way to get some random parts is to have them made halfway across the world, shipped in containers all the way over. Takes 3 months. Maybe it gets there on time, maybe it doesn't,
Yeah,
and you just have to kind of hope and guess.
yeah. Whereas if you had a network of low cost, 3D printing machines everywhere, so what if a city goes on lockdown and for some reason packages can't go in and out? Like you just transition it, you spread it around to other manufacturing sites nearby.
Hmm.
So it's like a rather than a supply chain, which is made out of really weak links, you
Yeah,
have a supply mesh where if any single, you know, production node goes down, the others can take up the weight of the demand.
that's a good
Um,
one. Supply mesh.
yeah, it's like a
Did you make that up or is that a thing?
well,
That's pretty cool.
it's like a
Supply
Wi-Fi
web.
mesh. I don't know.
Yeah,
Yeah, it was something
that's good to visualize. I like to be able to
we
visualize
were
these
talking
things.
about. Yeah, like I guess if you have a hole in a net, you don't throw the net out. But if you have like a hole in your chain, then the chain is useless.
Yeah, well, actually, that's a good one. You can still use a net with a hole to catch a fish,
Yeah.
but if your fishing line's broken, you're done.
Oh, that's wow.
Analogies.
Steph is gonna be very happy with this stream, I think. Um, so we kind of went off on a tangent there, but I that's the reason why like supplying spare parts is so expensive. It's just the way that we've decided that we've worked supply chains around high volume manufacturing like injection molding. It was an inevitable outcome of relying so much on it, things like injection molding. So where we come in, everyone watching, everyone who owns a Quinley, is using 3D printing and now scaling 3D printing to help pick up a lot of that manufacturing um, slack that has been caused by all of these. Like there's been, a dozen once in a lifetime events in the last year to the
Hmm.
supply chain network. It's
Yeah.
ridiculous. Um, but none of those events would have affected a large network of automated 3D printers, which is, why we think this is a really important discussion to have.
Hmm.
So let's talk about some of the benefits of digital inventory. So you'll hear that a lot with um, automated 3D printing and just 3D printing in general. This term digital inventory. What does that actually mean?
So a digital inventory is just a way to store your parts on a computer rather than storing them in a warehouse or on a shelf if you're a small business, for example. Um, but the digital inventory means that your parts don't take up any space and your quantity of parts is just a file on your computer. It doesn't take up any, you know, space. You don't have it doesn't take time to access those parts. You don't need to walk up, go to a different room, find the part on the shelf. It's just on your computer along with all the other parts, just
Mm-hmm.
in a big list. So it makes it really easy to look and find your parts and have them accessible just right in front of you.
Yeah, imagine if you could Google search your whole warehouse.
Yeah.
You can do that with a digital inventory. You just type in what you want and send it to the printer right next to you. Um, so that's yeah, exactly. Like there's a huge benefit. You don't have to deal with physical goods, and we've
Mhm.
seen how transitioning to digital has affected other industries that used to rely on physical goods. Like imagine if we still had to use paper mail instead of email, right? Like
Mhm.
complete difference in how we communicate and in the speed of communication. In the same way, you can make a complete difference in how parts are stored or spare parts in particular are warehoused, and the speed in which you can access them and produce them and get them to your customers.
Yeah, I'm just thinking right now, like imagine if Amazon, all their parts were 3D printed. Like
They
those
have
huge, massive warehouses could just be like, tiny little print labs.
they actually have a lot of patents around 3D printing, but I don't think they've ever used it.
Ooh,
Yeah, it's interesting. Like, but Amazon is known for having lots of patents.
maybe we have dinner with Bezos.
I don't know.
If you're watching,
I'll get.
Bezos.
I'm scared he'll shoot me off into space.
Well, maybe he'll join you.
Yeah, but it would like imagine Amazon just and it doesn't have to be everything. It can be things that you don't see. Actually, Amazon already does this, and it's like it's to get around international tariffs, but they will. And again, it's like shows how ridiculous the global supply network is. But they import things into Mexico, disassemble them, move them to the US, and then reassemble them so that they can say it's been built in the US and it avoids like certain international tariffs.
Wow.
And like I guess if you're already doing assembly in an Amazon warehouse, why not just make the parts there? Because then there are no tariffs that you have to deal with anymore because you'd be
Hmm.
making in the country that you're selling in. Um, and that's another thing with spare parts because they're often kept in one location. Your dish or your clothes washer, um, your spare parts might only be kept in Japan, and then it has to come over. You have to pay for shipping. You have to pay tariffs on the spare part, on the shipping, like customs fees or whatever, and that only increases the cost of your part. Whereas if
Hmm.
they had like one guy in a broom closet with like 10 printers in North America, they could cut down on 20 or 30% of the cost because of all the taxes and the import fees too.
Hmm.
And not only that, but they're giving a guy locally a job in the country that they're selling in, which is good too, and it helps with workforce supply issues.
Yeah. It's
Um,
also a cool job running an automated print farm. I mean,
you
pretty
don't have to
cool.
do
Yeah.
anything.
You just watch all your parts appear.
um, and yeah, like that, that affects. So we hit on smaller warehouses. Your minimum order quantity is one, which is really important for spare parts.
Yeah.
Um,
So you can actually just print one part because it's a printer,
yeah,
right? You don't need to actually get your mold out, put it into the injection molding machine, do one cycle, and then take the mold off and get your part. Like you can just print one part. You can't do that with injection molding. You have to injection mold like thousands of parts. Otherwise, whoever does your injection molding won't take your order.
and as Pat says, like more important than reducing warehouse space and shipping is just capital. Storing 10,000 parts, if it costs you $3, that's $30,000 that are locked up that you don't even know will bring value to your customer.
Yeah, actually should have mentioned that first way back in the beginning of our stream. But yeah, like the whole locking up of your money in potentially useless parts is a big risk that doesn't usually pay off in the end
It,
anyway.
it's a risk and it's wasteful.
Yeah.
And you could spend that money on better things, like on you know investing in better parts, new products, or vacation, pay your employees more. I don't know. You can like there's a million other things, better uses than $30,000 shit sitting in a box on a shelf somewhere.
For sure.
Um, yeah, and then the other angle that we haven't really talked about, but is sustainability. Like every single point that we've made so far also affects the environment and sustainability of manufacturing.
Yeah. So said earlier on in the stream as well, but supplying spare parts means you're overproducing spare parts just to make sure you're going to have enough for your 10 years of obligation. Um, and usually when you overproduce parts, that means there's going to be stuff left over at the end. And since they're 10 years old and they're only for machines that are out of date now, they're no use of anyone for anyone. So you just have to throw them out. Hopefully you can recycle them, but maybe they're not a recyclable part and you just have to dispose of them basically.
Or
So
they sometimes they degrade too. Like certain
yeah,
plastics will degrade over 10 years.
yeah. So that's also, they'll become worse over time and then they'll have to be thrown out. So it's not a sustainable way to to deal with spare parts really.
Mm-hmm.
Um, Also, just the fact that you have to, um, mass produce parts in the first place. Um, injection molding does have a decent bit of waste associated with it as well. You don't see it because all the parts look pretty nice and clean and smooth. Um, but there's a lot of plastic that needs to be post-processed off with these parts. Like there's runners and sprues and all this stuff that you need to have for the plastic to get to the part. But that's actually all just thrown away as well. We don't see any of that
Mm-hmm.
because
Because it gets,
it's thrown out before we get the
yeah,
part.
it doesn't even come to our country usually.
Unless you get one of those model airplane sets with those
The runners,
those built-in
yeah,
runners.
the runners and the gate, you cut the gates and the
Yeah,
flashing.
those are pretty
Well,
cool.
if it's bad, you have flashing.
Yeah,
It's bad quality. But yeah, this all of that stuff, and it's actually quite a decent amount too. It can sometimes be 10% by weight,
yeah,
which is imagine like having to. I guess you get this with some types of printing, but imagine like 10 to 50% of your part ends up being waste. I guess if you
hmm
use supports, that happens, but
yeah. Well, the way that we design parts, at least for production, we almost never use supports,
yeah,
and it's
those
actually
those.
not too hard to design to not require supports.
So this is an example of one of the parts that we use on our Ender 3, and we show this part a lot because it's really cool and it makes really clever use of 3D printing. Um, why don't you tell people about like the part design, and then we'll talk about how it was sliced and like how that affects the manufacturing.
Yeah. So what this part is it is a ramp that goes onto the side of an Ender or an Ender 3v2 or an Aquila, and they pop in using these built-in flexible clips at the bottom. And so these ramps are
Here.
designed, yeah, just so that parts don't fall in underneath the y-axis when it moves back and forth, because that can cause so many like bed leveling issues or just causing it to get stuck. So these just prevent that from happening.
So they're very thin. They're
1.6 millimeters.
yeah, they're 1.6 millimeters, but they have to be strong enough to prevent heavy parts from flexing them or knocking them out of the extrusion, right?
Yeah.
So how did you pull this off? So it's like a pretty simple angular panel design, but it's got to have these complex clips built in, right?
So this is all one part, and it was really only possible by 3D printing to have that design flexibility. So we can have a part that does multiple functions. You know, it's a shield, and it clips in, and it looks good. It has the Q logo on it on the other side. Um, so it serves like three different functions, but it's all just one part combined into each other. So that was only possible with 3D printing. And you actually get a cool view of just the kind of complex geometry and these overhangs that we're able to do using 3D printing.
And then the really cool thing that Steven figured out is if you print it in vase mode, we were able to, get the print time down about half of what it originally was when it was first designed. Actually, it's
It's
less
like
than half.
3 or 4 times less
Yeah, because it
time.
was it was I think the way back last summer or last October, they took about 3 hours to print.
Yeah.
And this part is pretty tall, right? I think it's 10 inches.
It almost maxes out the ender height. So I
Right.
think it's 215, 220
Okay, so
millimeters.
almost 10 inches.
Yeah.
And um, so as you can imagine, if you're printing it normally, it would take a long time because there's so many layers.
hmm
But we figured out, or Steven figured out a way of designing the entire part to be printed as a single wall, but still get all of the shapes that we need, which is
hmm
really important for these clips here, like for this clip, because it's got to fit in the aluminum really well.
Yeah. And so you printing it in vase mode means these layers are actually half a millimeter thick. They're really thick layers, but it doesn't look too bad. Like it looks almost like it's almost on purpose. Like
Hmm.
um, the layers just blend in with the product itself. Um, and in vase mode, actually, it helps make it stronger because instead of having specific planes, the layers actually kind of look like this as they go up. So it's
Yeah,
like a spiral.
and they cross too in opposite directions on
hmm
each side of the part, and that was something we only realized later because I was looking at one and I was just playing with it and I realized like this is way stronger than when we were first making them. And I was wondering,
hmm
is it a new filament or what? But it was literally just the way that you could, I think they call it like meta material science,
Oh yeah.
right? It's almost like by angling as it goes around in a spiral, by angling, each direction in this opposite to one another, um, whenever you flex it, because there's no break plane, you kind of get one half of the model supporting the other half. And it ends
Yeah.
up making it ridiculously strong for such a thin part. Um, just switch back to the video.
Yeah,
It
that's
was
an interesting side effect. We didn't plan for that. But it turns out that these parts are super strong and they also just look a lot better because there's no Z seam and yeah, they just print super fast too.
yeah. I guess we kind of are reversing into one of the questions with spare parts that every single manufacturer is going to have, and I think people in everyone watching, already agrees with us on this, but people are going to ask, manufacturers are going to ask, is 3D printing going to give me, let me back up. If I use 3D printing for spare parts, or automated 3D printing for spare parts, are the parts I'm going to get, will they be strong enough and will they look good enough? And, that's something that everyone says. 3D printing is weak and it's not going to look good. So how would we address that with a manufacturer? How do we show them that actually, in addition to all these other benefits, you can get final use parts from a 3D printer?
Yeah. So this is actually covered in one of the sections in the white paper. So this is the common concerns that people may have with 3D printing. So the layers in particular, it's like the first thing anyone ever says, like, oh, injection molded parts are smooth, 3D printed parts have layers. End of the story. I'm never gonna touch a 3D printer. Done. Um, but the fact is, like, layers don't have to look bad. It's just that sometimes the parts that you see weren't designed in such a way to make the layers look good.
Mm-hmm.
So what actually happens is when you do when you design for 3D printing, um, you design in such a way that the layers, first of all, look good, but also that they keep the part strong. So, um, the inherent weaknesses with 3D printing can also be mitigated by good design.
Mm-hmm.
So you can't just 3D print an injection mold file. A part that was designed for injection molding is going to look different from a part designed for 3D printing.
And it's because it was designed for injection molding, it's going to be best for injection molding.
Yeah, yeah. So you see like enclosures for electronics or tools or something. They all have like very uniform walls, and they're all very nicely um, thin, the exact same thickness all the way around. Um, that's actually just to stop the parts from warping while they're being injection molded.
Mm-hmm.
And also for other reasons, they have to have your part able to be released from the mold, so you can't have overhangs. So there's these design features and limitations in injection molding that you don't have with 3D printing. So actually, yeah, Mateo's scrolling through the white paper here, and actually this was published in the Appliance and HVAC Report. So this is a magazine that does, I think, 4 issues a year, and they cover everything from like air conditioners, motors, pumps, valves, how to choose the best, screw. It's actually pretty cool.
It
Some of the
is pretty
articles
cool, yeah.
are interesting.
Some people would find them.
Yeah, look at this. They have tape, energy, sensors, testing, motors, and 3D printers in this issue. And we're the 3D printing article. So it's a pretty cool magazine. You should check it out. We're on page 32.
I'll post a link to the whole. But this white paper that Steven did is like super in depth and it goes through an actual use case. And we'll talk a bit about the use case.
Yeah, so that's going to be our final topic on the screen here.
Yeah.
But it's actually good to see some of the like the graphs and just the parts. We'll show this in better detail later.
Yeah, we'll show it in a bit.
But yeah, so the common concerns people usually have are aesthetics. So the layer lines, they don't look good all the time. But what ends up happening is a lot of spare parts, you don't actually see them. They're actually hidden inside the the enclosure of the appliance in this case.
Yeah.
So for example, like a dishwasher has all these buttons on the front of them, or like a washing machine has, dials and knobs. But behind that panel, there's all these plastic mechanisms and like flexible little plastic bits that move and hit buttons on a circuit board. You don't see any of that, but those are spare parts, and those things can break, those things can wear out, and they need to be replaced every once in a while. Um, so when you don't see something, it doesn't matter if it doesn't look smooth and shiny.
As long as it hits tolerances,
Yeah, as
which you
long as
can
it's
get.
built to tolerance. And
Yeah.
a lot of our customers are building stuff to pretty tight tolerances.
Yeah. Yeah, 3D printing can absolutely hit those tolerances. And I mean, that's just completely sidestepping the argument that 3D printing doesn't look good, which I would argue against. I think you can make it look really nice, but
Yeah, it was just another point there. So you
yeah,
can design parts to make it look good, but even if you can't, you don't need to show your part because it can be hidden inside, which is likely what it's going to be needed for
actually,
anyway.
while you explain this, I'll find an example of a really ugly internal part that was found in an actual product that
Yeah.
was 3D printed.
Ooh,
Yeah.
all right. Let's look for that. In the meantime, I'll cover the last common concern. So we covered the aesthetics of the part due to 3D printing, the layers. We also have the strength of the part, so you can redesign parts for 3D printing and actually, use things like phase mode or, um, just making parts bulkier in the Z direction so that they're stronger. So the last one is actual material properties. So sometimes you'll need nylon, sometimes you'll need a UV resistant material, you might need chemically resistant materials, or you might need something flexible like polypropylene. Um, and all of these can actually just be 3D printed now. There's a lot more materials available than there were like 5 or 10 years ago. Um, and they're actually good for 3D printing now too. Like a lot of work and engineering has gone into the materials so that they can be 3D printed nicely.
Yeah. When you think about 3D printing in 2012, people were using weed whacker line as filament. And I think
Yeah.
that also happened to be when, 3D printing entered the mainstream. So a lot of people, see 3D printing in its, or have a concept of 3D printing when very early on when printers were really janky, the materials were not there, they were not purpose built for 3D printing.
Hmm.
But now that it's 10 years since then, and materials has been one of the fastest, growing areas of innovation in the industry. It makes up a third of the 3D printing industry. Um, and as you said, the stuff available now can kind of address all of those concerns, I would say. I found a picture of the part. So this was, it wasn't a spare part, but it was an emergency part, and it was printed to keep a production line from going down for cars. And I mean, I would say that is objectively not a beautiful part,
Yeah.
but this part sits inside the chassis of a Tesla Model Y, which is a very nice looking, very expensive product.
Hmm.
Yet it still looks like this because no one will ever see it. Like, I think that's a perfect example of
Yeah.
if someone complains about print quality, just remember, like, your dishwasher might have 1,000 or like a few hundred parts in it, maybe not 1,000. But how many of those parts do you actually see?
Hmm.
Most dishwashers, the ones that come installed under a counter, don't even have side plates or a back plate. If you ever pulled one out, it's
Yeah.
just completely exposed. And you would never know because you never see that.
Yeah. And if you actually take a look, there's a lot of just plastic components that do very little. Like they have just a very small purpose, like they keep a wire from moving too far this way.
Yeah.
It's not like, you need like, a whole impressive, like high tolerance, um, piece of like linkage that does all these complicated motions. You just need a part to hold a wire or, you
Yeah.
know, push a button or something.
So the argument to manufacturers would be, let's start with these parts because these are also the most annoying parts to keep in stock
Hmm.
and replace, and because it's so unlikely they'll ever break. So you can start there and eventually move up.
Yeah.
And I mean, the end goal, I think, for a lot of manufacturers would be starting from spare parts, validating the technology, and then moving into using 3D printed parts from the get-go, and actually having 3D printed and 3D printable components in the original machine.
Yeah.
Because that just, that solves so many of your problems.
Yeah. And so you can actually you can benefit from the, printing on demand, lean manufacturing, the just-in-time manufacturing capabilities of automated 3D printing. And you can incorporate that into product design, which is pretty cool. You can design your product to benefit from those um, benefits.
Yeah. Here, Bob has a good point. He says budget printers allow for easy entry into the market, and then Quinlay helps us better utilize those functionalities, which allows for better printers as need or profits allow. So that
Mhm.
is actually something that we're trying to help facilitate for sure, with people who use Quinley. You typically the pattern seems to be, especially in farms, is you'll get one and you'll start using it, and your printer is going to work way more and way harder than it ever has, and it's going to output way more parts, because it's now self-reliant,
Mhm.
automated, and the Quinley ends up paying for itself in a matter of a few days to a few weeks, and then it starts paying for the next printer and the next Quinley, and then
Mhm.
you get another automated printer, and what you'll find is because Quinley is now making total use of the functionality instead of the printer relying on you to do its best, um, you'll find that scaling to more machines becomes really, really easy.
Mhm.
I think a lot of people would think, oh, well, if I can get 3 times more prints out of my machine with Quinley, why would I bother buying more printers? When actually it's more like I'm now making and selling 3 times what I could on my machine. So now I can think about buying, and I have the time to buy and run more 3D printers. So you end up actually producing more on your original printer and getting more printers. So that it demonstrates just how scalable the platform is.
Yeah. Well, you don't have to spend all your day worrying about your 3D printer. You can actually spend it, marketing to get more demand
Yeah.
so that you can get more 3D printers to meet that demand and
Or
get,
designing more products or whatever.
yeah.
We've got Sanford in chat.
Oh, Sanford, hello.
It's nice to see you. Sanford
It's been a
is
while.
former intern
He's
on
doing some
production.
cool stuff with his 3D printers. He's actually looking at some upside down printer design.
Yeah,
Really cool.
it's super cool. Um,
So we're almost at the end of this, the white paper. We probably want to look at the results of the white paper.
yeah, so we've been talking about all these issues, how printing solves it, but when applied to an actual use case, um, like in real terms, what does it look like? So I'll switch back to the white paper view. And why don't you tell everyone what the use case you were looking at was?
Yeah, so I was looking online for a spare part that was, a plastic part that a lot of people might have actually seen or used before as well. Um, and so this is what's called an agitator dog, and it's found inside pretty much every washing machine. Um, the ones that are top loaded with a spinner,
Mm-hmm.
and it's these guys actually are used to keep the spinner moving one direction, and then sometimes the base will move in one direction, but the spinner will still move in this other direction because of these dogs. So they have these little gear teeth built in, um, so that they bite into another gear part in one direction, but they like let it slide in
Is
the other. So it's a ratchet.
it's a ratchet. Is
Yeah,
that why they're called dogs? Because they bite?
yeah, I guess so.
Okay.
I haven't thought about that too much, but that makes sense. So we've actually got the Whirlpool part number. It's 840, 80,040. Um, and it's a common part. You can find this everywhere, essentially. But it's a good use case because these are injection molded at huge scale, and they're found in tons of different washing machines uh, in the world. So it's an interesting one to see like how much would these cost to automated 3D print. So what is the cost per part for, one? What is the cost per part for, 100, 1,000, 10,000? Like when does automated 3D printing stop making sense for these parts? Um, so what we did was looked at the cost it would have taken to injection mold them. So injection molds, we were talking maybe 15,000, maybe 20,000. Um, yeah, if you look here, these are the results. So we were assuming for a 300K, 300,000 batch of parts. The mold cost would be 18,000. It's likely a more complicated mold. There might be like multiple cavities to make the process go quicker. It's probably got to be made of a better material, got to be harder so you can actually do 300,000 cycles. So we're assuming the mold cost is 18,000. Um, and when you injection mold 300,000 agitator dogs, comes out to about 6 cents per part.
This is with no production cost.
Yes, so we've actually neglected a whole bunch of costs. This is just 18K divided by 300K. So
This is
it's
not
just the
counting.
mold cost being spread out across all the parts.
This doesn't count things like the cost of contracting to actually do your production run, the cost of waiting for your production run to happen, the cost of shipping materials and parts back to you. This is purely off of mold cost. So it's a very conservative estimate for a production run of 300,000 parts.
Yeah, because we do 3D printing. We don't claim to be experts in injection molding. So I'm going to give every benefit of the doubt and say, okay, parts are free, labor's free, shipping's free, the mold is 18K.
Yeah.
So I think that's pretty fair. If you don't think it's fair, let us know in the comments.
Yeah. Actually, let us know.
Because yeah, maybe we got it wrong. But uh, yeah, we took every step to kind of be generous here. Um, so let's look at 3D printing. So um, using the manual 3D printing technique, um, there were a couple uh, limitations. So the first one was the labor cost. Um, we're actually assuming that there's an operator who spends, I think it was 10, no, it was 5 minutes every cycle of parts
For
um,
manual 3D printing.
for a manual 3D printing. Yeah, this is all, oh, 3 minutes to restart a print.
There you go.
Yeah, so having this 3 minute time to restart a print increases the cost per part by 5 times. So it becomes 28 cents per part instead of 6 cents a part, just because of this 3 minute restart amount. Um, so that's pretty small. I mean, I don't think a lot of people actually take 3 minutes to restart a print. You know, sometimes you have to actually get up, you have to walk over to the printer, do all the stuff that's required, and then sit back down. You forgot what you were doing before. You know, maybe you go and make a cup of coffee and browse Reddit for 10 minutes because you forgot what you were doing.
And you forgot to start the print or something.
Yeah.
I've done that.
So 3 minutes, again, it's a fairly, I think it's reasonable. Um, anyway, and then you get paid $18 an hour. That all can get mathed out to be 28 cents per part. Um, and so the fact is when you automate a 3D print, um, there are only a couple costs that go into that. That is the cost of the automation itself, which is Quinley divided by the year, because you're assuming we're printing 24/7 across this year. So you can actually find out how much Quinley costs per hour, and it's about 2 cents. That's pretty good. So 2 cents an hour, and then also just the material itself. So we've found that to be about 4 cents for this small little agitator dog. So combine 2 plus 4, 6 cents. That's breaking even with injection molding at 300,000.
Yeah, and if you read through this white paper, it goes into a lot more detail, and you can see that we've tried to give pretty much every benefit of the doubt to manual 3D printing and injection molding here. So these are very conservative estimates for the crossover. But even still, you're looking at a crossover with 300,000 parts. And should I show the graph maybe?
The graph's good. Yeah, I gotta go for it.
Okay.
So the graph actually shows the curve of injection molding versus the flat lines of 3D printing.
Hold on, I need to make sure that we're not obscuring it.
Is my head in the way?
Uh, yeah, we might be in the way.
Oh, you could actually just throw us to the back of the of OBS. That would
Throw us underneath.
yeah, put us behind.
Good idea, good idea.
But in general, the cost of 3D printing is static because you don't have any cost to spread out over all your parts. Yeah, this works. You can see it for a bit. Um, and the curved line is injection molding because, when you have a small batch of parts, it costs a lot. When you have a large batch of parts, it costs less. And there's all the steps in between. So it's just a curve. Um, so I actually stopped the graph at 10,000 parts because you couldn't even see 3D printing once you got to injection molding at lower levels. Like it would be the y-axis would go up to like 1,000 or something, and then you just have like a red line squished under on top of a green line
Yeah,
right at zero.
yeah,
So yeah, injection molding really only like becomes kind of feasible at 10,000 parts. Um, and actually automated 3D printing was more feasible up until 300,000 parts. So just an interesting way to show the power of automation and that this isn't just like some, you know, speculation. There's actual math that supports um, these claims that we're trying to make here.
yeah. Math and actual data that we've collected and data that our customers have collected as well on their own production. So it is showing like it is kind of this is really dispelling the myth that 3D printing can't be used cost effectively. It's
Mm-hmm.
actually the most cost effective option until 300,000 parts, even cheaper than injection molding, less expensive than normal 3D printing, obviously. And the crossover in a best case scenario for injection molding, which is like you have this machine on your desk, is still 300,000 parts. I bet that if we were to factor in all the costs of um, contracting out the manufacture of these parts for injection molding, that the crossover would be somewhere around 500,000.
Mm-hmm. Yeah, and there's also in the white paper itself, there's a few more sections talking about sort of um, like the labor and a few other like post-processing downtime, and some of the costs that we've either um, decided to say, oh, they're about equal, like defects, for example. Say, oh, injection molding parts have defects, so does 3D printing.
Mm-hmm.
We're going to say that they're about the same because they're negligible. Um, yeah, it's funny, the like a lot of things become negligible when, we have a mold that costs 18,000. Um, so that's why we just said, oh, everything is free.
Yeah,
The mold is expensive.
even if it was a 10% failure rate, your part cost would be, 6.6 cents and not 6 cents.
Yeah.
When we're looking at differences of 500%, that kind of thing becomes pretty negligible.
Hmm.
So yeah, that is a super interesting and impressive result. Like I think that is so cool. Like
Maybe we
it's
should get in front again. Are we in?
we're in front.
We're in front?
Yeah.
Okay, just making sure.
Don't worry, you're not hidden by the graph.
Cool.
But yeah, I think that's a super interesting result, and I hope everyone watching will share this and be like, see, I told you.
Yeah, well, I think some people could really at least benefit from like watching this or reading the white paper if you
Hmm.
don't have the time to watch it. But um,
Yeah, I'll
yeah, if you
post
want
it
to
in the
change some people's minds, yeah, there's also a link actually in the description of the YouTube video. Um, but yeah, Mateo posted a link in chat for uh, a magazine that we're into. They did a really good job of
laying it out.
like formatting it. Yeah, it
Yeah,
looks really good.
it looks really, really nice. And there's a little picture of you.
Yeah,
It's my
yeah.
favorite part of the.
My little bio headshot.
Let's find it. There
Yeah,
you are.
there's me.
7 years.
7 years, way back in high school.
Oh, me too.
Yeah, grade 10 actually is when I first started 3D printing.
I think I got my first printer in the summer of grade 10 too. Yeah. Industry veterans.
Yeah,
Just kidding.
yeah. How many people say they have 10 year or 7 years
Seven
experience
years
in
of
3D printing?
experience.
I mean,
Yeah.
not a lot of people actually.
Well, people work with like resin printing.
Yeah,
We're part of the new wave, I
the
think.
rep rap printers, I guess.
Yeah,
We
fine.
have to do things the hard way a
Yeah,
lot of times.
yeah,
So
avoiding patents and stuff. But uh, yeah, this is like definitely the new wave of actually people who started with rep are now entering the industry.
hmm
And you see that like the industry is changing quite a lot, and I think the next couple of years are going to be really interesting. Um, because it is a completely different perspective, and yeah, a lot of people are bringing it into their workplace now, or straight up just working in 3D printing.
Cool.
All right, well, um, I think that's pretty much it for the stream. So good timing, Ben. You made it to the end. Everyone else watching, thank you for joining us to the end. Um, should we recap?
We could just do a brief summary of
Yeah,
beta, maybe.
let's do a brief summary. Why don't you give everyone a brief summary? I'll show the website again.
This will be even briefer than last time, don't worry.
Okay, super quick.
So we're starting a beta program for all of like 3 new printers, CR10, CR6SC, and Sidewinder. And we have a beta sign up in our shop on our website. Click the shop button, click the beta testing button, and you can get um, a link where you can just plop your email in there, and you'll get updates about our beta program. And we're doing these beta programs, giving our beta testers a discount, um, and in exchange, the beta testers help us develop the product and also the future of 3D printing automation.
Mm-hmm.
So I think it's a pretty cool program to get involved with. We have a separate Discord space set up for beta testers too. Um, so you can join in and check out the beta tester lounge, say hi.
You get to be the first to get automation on your 3D printer. You don't have to buy a special 3D printer to do this. You can use the printer you know and love.
Mm-hmm.
And yeah, we've had a really good response so far. I think we have about 700 people signed up on our list, and I mean, even before we formalize this program, we have about 20 beta testers for new software that I've been working with, and we've
Mm-hmm.
worked with dozens of people on the product launches that have happened so far, and now we just have a more streamlined, efficient way of doing it. So yeah, if you're interested, um, hit that beta testing link, throw in your email. We'll contact you shortly after that, and get a sense of what printers you have, what printers you'd be interested in helping automate. Um, yeah, we can help. We can kind of build the future of 3D printing and hopefully the future manufacturing together on this. So that's yeah, it's gonna be cool. It'll be a lot of fun, I think. Um,
Yeah. And quick recap over the stream, we were talking about how automated 3D printing can be a solution to plastic spare parts and the spare parts crisis that has been happening, mainly due to right to repair laws and having to supply parts over 10 years. It's all in the stream. Check it out. And if you don't want to watch the whole video, if you just got on right now, we have a white paper that we wrote. It's in the description. It's also on our website. Um, it's a good read. There's a bit of math at the end. I don't think it's too much though.
no, it's pretty.
You have to have some math, otherwise we're just talking words.
Yeah, yeah. It's math based on real data from our own use of 3D printers and the use of other Quinly users, things we've learned from them. Yeah, and automated 3D printing, because it's so efficient, because it's so lean, is almost a perfect match for things with unpredictable demand, like spare parts, where you have to have dozens or hundreds of different parts available at the drop of a hat. And
Mm-hmm.
what better way to deal with that kind of demand than keeping all your parts in a file somewhere on a computer and having an automated 3D printer that can print that part whenever it's necessary
Yeah.
rather than having to plan 10 years in the future and figure out which parts you'll need and how many extra you need to make, and lock up a ton of capital into inventory that may end up in the trash 10 years later. So,
Yeah, you can just use an automated 3D printer to pump out 1 or 2 parts a week. Maybe near the end of a product's life, it's 1 or 2 parts a month,
mhm.
and you don't have to have all the costs associated with having a warehouse and having, shipping and fees and everything.
And the best part is when you're not using your printers to make spare parts, you can use them to make anything else, make new parts,
Mm-hmm.
or make parts for an upcoming product. It's that flexible.
Yeah, you can just shift your capacity over from one project to another.
Yeah.
Cool. Thanks, guys, for tuning in. It was
Yeah,
a fun
that's
stream.
we hit 500 subscribers. Make sure to hit like on the stream, and yeah, it's actually this week. This week is 1 year of Quinley.
This is our Quinleyversary week. Yeah. So it's actually cool. We hit 500 subscribers the same day that we um,
The Quinley,
technically
yeah,
are 1 year old for Quinley.
1 year old for Quinley. Yeah,
Very cool.
expect some cool stuff between now and then 3DQ's 3 year birthday in November.
Yeah, there's going to be a few cool things going on.
Awesome. Well, thanks everyone for joining, and we'll see you next week with another stream. And thank you everyone for the birthday wishes, and also for joining us in chat. It's been awesome talking with everyone. Bob, Pat, Kevin, of course, Justin 3D,
Sanford too.
Sanford too came back. Our 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 famed production intern who was on the stream once.
Yes, we talked about his packaging.
Yeah, that's a stream I would recommend.
Yes, check
Another
that out.
cool
If you're
use
looking for
case.
more, check out the packaging stream because that's really cool.
It's super interesting.
It's very good if you actually are struggling to look for packaging for your own product. You could 3D print it with Quinley.
Yeah. All right. Kevin's gonna have a birthday party for his twins. We will too. All right.
All
All
right.
right.
Bye, guys.
Bye everyone.